lines. The reason why there isn't a specific assignment for these is because there's a very clear pattern as to how these work. And once you figure out the pattern, it goes really, really, really quickly. And so there will be, like I said, there's a couple questions on tomorrow's review assignment that are going to be like what we see on here today. But in general, these ones are going to move pretty darn quickly. I will say, though, that this is one of the lessons that people will get mixed up in terms of which one's horizontal, which one's vertical. So I'm going to try to give you a couple pointers on how to remember that. Miss Eddie, if you have any great ideas on that as well, let me know. And we can work through it. We'll just kind of be able to see what's going on in terms of writing equations and then graphing these, and we'll go from there. So let's jump right in. Talks about vertical lines first. It says that a vertical line is written in the form of x equals a, where a represents the line's x-intercept. So what that means is the equation of a vertical line is not slope-intercept form. It is not standard form. It's its own different thing. And while that might sound confusing, it's probably the simplest type of equation that we've seen so far to represent a line. So a vertical line, this one right here, as long as you know the x-intercept, you know the answer. Yesterday, we talked about x-intercepts and y-intercepts. We said that the x-intercept is where the line crosses the x-axis, and we said that the y-intercept is where the line crosses the y-axis. So can anybody tell me on this first example here, where does this line cross the x-axis? Ash? Look at basically what? Yeah, exactly. You look at the line and you figure out where does it cross the axis, right? And so a vertical line will only cross the x-axis. The vertical line will never cross the y-axis. Yeah, it's at 3. A horizontal line will only cross the y-axis. It will never cross the x-axis. So if this line here, this line crosses the x-axis right here at 3. So yesterday, what would we have written for the x-intercept for this? 3, 0, or x equals 3, right? And that's the answer to this problem, x equals 3. Whatever that coordinate is our answer. So if it crosses the x-axis at 3, the answer for this equation for that line is x equals 3. Likewise, if it's a horizontal line, it's going to cross the y-axis. Wherever that line crosses the y-axis is the y-intercept, and the y-intercept is the answer. So what is the y-intercept of this line right here? Where does this line cross the y-axis? At -1, yeah. So it's y equals -1, exactly. So whatever the intercept is the entire equation. That's it. And while that might seem like almost too simple, it almost seems like one of those trick questions, like, is that it? The answer is yes, that is it. So whatever the x-intercept is for a vertical line is the answer. X equals whatever that number is. Horizontal, wherever the y-intercept is, y equals that number, and that's it. It is a pretty simple thing to do, and in pre-algebra, this is one of the topics that doesn't necessarily have to be included in pre-algebra. So you'll see slope-intercept form in pre-algebra. You'll see graphing, diagonal lines in pre-algebra, but you won't always see horizontal and vertical lines. So yeah, because especially with like math and science classes, there are so many things that we are required to teach you in the class in order for you to earn the credit, that some of the things that aren't required to be taught sometimes aren't taught because teachers will focus on the things that they have to teach you. And so sometimes things like horizontal and vertical lines we won't necessarily be working on. Or what was it last week? there were some problems on one of the notes pages that I said, hey, cross all these off. We don't have to do those right now. So that's the kind of thing that we're talking about. So the things that you crossed off last week on those notes, you might end up seeing in future classes, which will be teaching it to you then. So yeah, sometimes things have to get cut, sometimes not. You know, it just depends on what needs to be taught, what should be taught, and then what we have time for if there's other things. So let's take a look at some examples here. So problem number 1. And you might notice that I'm actually putting a dot on the intercept here. That's always a good idea, just so you know, like, hey, there it is. That's the line that I'm talking about right there. The line crosses the x-axis. So the answer is going to be x equals. If it crosses the x-axis, it'll be x equals. And where does this line cross the x-axis? -2. So the answer is x equals -2. And that's it. We'll do one more as a class, and then I'm going to have you work on 3 through 6 on your own. So number 2, this one crosses the y-axis. What is the y value for where this crosses the y-axis? How far up is it? 3. Yeah, it equals 3. It crosses the y-axis at 3, so the answer is y equals 3. And that's it. So for the rest of this page, I would like you to work on 3, 4, 5, and 6. I'll give you a couple minutes on that. And then I will be calling on people randomly, just to see how we're doing on this. So I'll take this time as well to get attendance figured out, and we will go from there. So let's see, make sure I get my numbers right here. 27. All right, so first person, Gwen, what do you have for number 3? What is it? Y equals -5. Nice. So on number 3, we have a y-intercept right down here. And that is at 1, 2, 3, 4, 5 down from the middle of the graph. So that's -5 on the y-axis. And because it's the y-axis, it's a y equals, and that number is -5. Excellent work. So number 3, y equals -5. Problem number 4, let's hear from Creighton. What do you have? Yeah, sure. So that one there, yeah, 5's a little tricky to actually see which line it actually is talking about, and it is x equals 0. Good. This one here is a vertical line right in the middle of the graph, and it crosses the x-axis at 0, so that would be x equals 0. Good. The only way that you can tell that the line is the vertical line is the fact that the arrows at the ends are bigger. So that one's a little bit tricky to see. But yeah, you got it. Nice job. Next, Elena, what do you have for number 4? X equals 4. Nice. So we have our line crossing the x-axis, which tells us that the answer is going to be x equals whatever number this is. It is 1, 2, 3, 4. So x equals 4. And the last one on this page, number 6. Let's go to, let's see, not here. Kaden. Kaden, how's it going? Do you have any of these notes written down yet? Were you able to hear a little bit about what was going on? Let's try number 6. You'll be able to pick this up pretty quick. Where does this line cross the y-axis on number 6? You can use your own paper too. Yeah, +2. All right, so because of the y value of the y-intercept is 2, then the entire equation is just y equals 2. Cool. There we go. Thank you. All right, let's go ahead and move on to page 2. Any questions so far? All right, second page. This one's going to work pretty much backwards from what we just did. Instead of being given the line and writing the equation, you are given the equation. You have to make the line. So it said get a ruler up on the board before class started. If you still need a ruler, if you don't have one yet, go get one. It's always a good idea to use a ruler when you make a graph. So go get a ruler if you don't have one yet, and then we will graph these 6 lines and then move on to the very last part of the lesson. All right. So all you need to do on these ones is place the point on the axis and then just draw a line straight through it. So for example, on number 7, it says that y equals 5. So that means it is going to be a horizontal line because it's through the y-axis. So from the middle of the graph, you're going to count up 5 spaces. So 1, 2, 3, 4, 5. There's y equals 5 right there. And through that point, the only way to get a line really through that point would be a horizontal line because it goes through the y-axis. So we're going to draw a horizontal line through that y-axis up there at positive 5. And that will be our answer for number 7. So there it is. So that is the line y equals 5. The next one says x equals -1. So we're going to put a point on the axis where it says here. So then we're going to put a point on the x-axis at -1. So there's our x-intercept right there at -1. And because it's x equals, it's going to be a vertical line. So we'll set up our ruler right here. We'll get our line. Arrows at each end. And that's our line right there, right next to the y-axis. So take a couple minutes. I'd like you to try 9, 10, 11, and 12. And we'll check in on those answers in a couple of minutes, and then we'll finish things up with 13 through 18. All right, so let's go ahead and have a look at these last four before the final questions at the bottom here. So number 9 says that x equals 3. You'll notice that I've got the point on the x-axis here. So if it says x, it goes on the x-axis. If it says y, it goes on the y-axis at whatever number it says. So x equals 3, we put that on the x-axis at 3, which means that we'll have a vertical line here. So we're going to go straight up and down. And that is our line right there for number 9. On number 10, it says y equals -2. So we go to -2 on the y-axis. We put a point from that point right there. A y equals equation is going to be a horizontal line. And there's our line for number 10. Any questions about those two? All right, number 11 says y equals 4. So that is the point goes on the y-axis there up at 4. So up 4 spaces, it's right here. If it's just a y equals a number, that's going to be a horizontal line. Up at +4. So there's that. And then the final one here, the final graphing one, number 12, it says x equals -7. So we're going to put a point on the x-axis at -7. So right here, second from the last over on the left. That will be a vertical line. There we go. There's number 12. Any questions on 9 through 12 before we look at the final problems here? Okay. Before we do that, I've got a couple of quick questions for you. If you have a horizontal line, let's see if I can find my notes here on this. It's been a little while since I've actually put things into my notebook. What's that? It does have a lot of stuff in it. It's everything from the school year in here. So yeah, it's all the pages of notes that I've done in this classroom since the beginning of the school year. So lots of stuff. All right. Let's take a look at number 7 real quick. Who can tell me what the slope of this line is right here? Yeah. Who can tell me what the slope of the line is on number 7? And if you're not sure or you don't remember, I would like you to look at your notes from the very first day we returned from break, last Monday. The one where it says rate of change in slope. This is from last Monday. I want you to look at this first page of notes. If you don't remember the slope of a horizontal or vertical line, I want you to look at those notes real quick. Zero and undefined, which is which? So this one here, number 7, that would be 0, and number 8? Undefined. Good. You remember that from last Monday? So we had types of slope on that first page. And if it was upwards diagonal, that was a positive slope. If it's going downwards diagonally from left to right, that was a negative slope. Perfectly left and right, horizontal line, slope of 0. Perfectly straight up and down, vertical line had an undefined slope. Yes. Yeah. Uh-huh. Uh-huh. Yes. Yeah. Yeah. Yeah, I like that. The horizontal and 0, I like that a lot, which really only leaves room for vertical being undefined. Yeah, that's good. So horizontal, 0, those ones go together, which means that vertical and undefined have to go together as well. So number 7 would have a slope of 0. Number 8 would be undefined slope. Number 9 has an undefined slope. Number 10, slope of 0. Number 11, slope of 0. Number 12, undefined slope. So let's look at 13, 14, and 15. We only have 2 options, by the way. If you notice that, the only options for horizontal and vertical line slopes are either 0 or undefined. So if we look at 13, 14, and 15, it asks us, what are the slopes of these lines right here? And as long as you can figure out by maybe looking back at some of the graphs, what type of a line we have, you can give the slope. So on number 13, it says, what is the slope of the line y equals 4? We have one of 2 options. It's either 0 or it's undefined. So if you need to look at some of the graphs to see which ones are the y equals, take a look and then tell me, what do we have? What's our slope for number 13? Yeah, m equals 0. Every single line that's just y equals a regular number is a horizontal line. Here's y equals 4, y equals -2. We got y equals 5. On the first page, we had y equals 2 down here. We had y equals -5, y equals 3. Those were all horizontal lines, which means they all have a slope of 0. So if it is y equals just a number, our slope will be 0. All right, how about the next one then? 14, x equals -2. What's the slope? Undefined. So an x equals a number gives us an undefined slope because that is a vertical line. So then 15, what's that? Undefined as well, good. So 0, undefined, undefined for 13, 14, and 15. All right, a couple more questions here, and then we've got one last graph at the end. So it says 16, which axis is y equals -1 parallel to? So let's look at a y equals graph. Here's a y equals graph right here, y equals 4. Let's see, we've got our x-axis here, we have our y-axis here. Parallel, by the way, what does parallel mean? We haven't talked about that at all this year. What is parallel actually means same as. So perpendicular would be opposite to. Parallel is running in the same direction. So like train tracks, right? Train tracks are parallel because they run side by side. So with a y equals 4, so with a y equals a number equation, that's a horizontal line, which axis is running in the same direction as this line, the x-axis or the y-axis? So we have a line like this. Which axis also is like this? The x-axis, exactly. So number 16, which axis is y equals -1 parallel to? That would be the x-axis. Horizontal lines are parallel to the x-axis because they run in the same direction, left to right. So then what would the answer be for 17? The y-axis, yeah. A vertical line is parallel to the y-axis. Okay, last question here. And I've been mentioning something, I've mentioned this type of thing a few times over the last week and a half. And it has to do with writing your slope as a fraction. And so I want to just kind of explore this for a minute. How does the graph of y equals 3 differ from y equals 3x? Graph both and explain. So first of all, let's graph this first one. So in order to figure out how they're different from each other, we need to be able to see them. So this graph here, y equals 3, we'll do this one over here. And y equals 3 is just like what we've been working on today. It's a horizontal line. We put a point on the y-axis at 3. So we're going to go up 3. 1, 2, 3. Put our point. And then we'll just draw our line, which is horizontal, straight across. And so there is the graph of y equals 3. Now we also are needing to graph y equals 3x. How is this one going to look? Or what information do we have about this line right here? This one's like the ones we've been doing previously. So what do we know about this line here? What's that? There's an x, yeah. The x makes a big difference. And what does the 3 next to the x represent about this line? What's that? The x-axis, not quite. So let's think about this for a second. We've got 2 other forms of writing equations. We have slope-intercept form, y equals mx plus b, and we have standard form, ax plus by equals c. Is this one here in either slope-intercept form or standard form? Is it in one of those 2 forms? If so, which one? We've been graphing a lot of things like this recently, right? Y equals mx plus b. What does m stand for? What's the slope of this line? 3, yeah. And as a fraction, that would be 3 over 1. We have a slope on this one of 3 over 1, which means up 3 and over 1. What's the y-intercept of this line right here? 0, 3, yeah. So the y-intercept is, it's actually not 0, 3, sorry, it's 0, just 0. The reason it's 0 is because after this right here, the 3x, there's no plus or minus any other number, which means it's nothing, which means it's 0. So b, the y-intercept equals 0. So just a reminder, everything that we've learned so far still applies here. So we're not changing anything about what we've learned before. I just want to make that really clear. Nothing that we are learning today changes anything that we've learned before. It's just a different type of line that we're looking at today. Very specific types of lines today, horizontal and vertical lines. This y equals 3x, though, this goes back to what we've been working on recently, where we've got our diagonal lines, and we have a slope of up 3 over 1, and we have a y-intercept of 0. So on our graph, we start by placing our y-intercept on the graph, which is right here in the middle at 0. And then from that point, we apply the slope. We go up 3 and over 1. So 1, 2, 3, and over 1 right there. And we can run this backwards from this middle point as well. Instead of up 3 to the right 1, we can work these in both of the directions can be opposite, down 3 and left 1. We can work backwards on both of those arrows just to get another point to line everything up. We saw this as we were graphing slope-intercept a couple days ago. And then we'll go ahead and line it up with our ruler and draw our line straight through those points. So there it is. So let's talk about this for a second. How does the graph of y equals 3 differ from the graph of y equals 3x? So what differences do we notice? So I like what you're saying there. So y equals 3. Yeah, that's another difference. So y equals 3 only needs 1 point to graph. And this one over here we use 3 points to graph this one. Yeah, I like the y equals 3x goes through both axes. So y equals 3x goes through the x-axis and the y-axis, whereas y equals 3 just goes through the y-axis. That's another thing. Yep. What else? What other differences do we notice? We don't have to write all of them, but what else do we notice that's different about those two graphs? There's a lot of differences. Good morning. What else do we notice about differences? As soon as Alyssa gets back. Any other differences that you see? Let's get one more. One more difference here. Elena? What's that? So we have a positive slope and a zero slope. Yeah. So zero slope versus positive slope. Cool. I like it. So there's a lot of differences that we could potentially be talking about here. But those are definitely some main ones. I would definitely say that. So that's it for our notes for the rest of the week. You do not have a new assignment that you are getting today. So that means right now you've got about 30 minutes to be working on a few different possibilities.